Hi Ben! Right, I tried to explain this by text but it didn't work, so here's the video. So what we got here is you've got a ladder, and we've got 1, 2, 3, 4, 5 forces labelled on it, and we know that the ladder isn't moving, and therefore we've got to work out coefficient of friction in terms of the angle it is making here, which we're going to call alpha. So, if the ladder isn't moving, two things must be true. The first is that the force up must equal the force down, and the force left must equal the force right. Because if either of these statements weren't true, the ladder would be accelerating up, down, left, or right. Easy enough. However, something else must also be true if this ladder is static. And that is something called the principle of moments. And I'm not sure how much you know about this, so I'm just going to go real slow on this. The principle of moments basically says that whenever something is in equilibrium, the moments turning it to the left and the moments turning it to the right have to be equal. There can be no overall turning effect, no overall moment. This is also sometimes referred to as torque, but that's just confusing, so I'm just going to use the word moment. If we consider a seesaw, if I put a mass here and a mass here, and this is balanced, you would know this mass must be heavier than this mass, because the rules for moments are the force is, the moment is equal to the force times the distance. So this mass times this, the force from this mass times this distance must equal the force from this mass times this distance. So the clockwise and anti-clockwise moments are equal, and this seesaw will stay in equilibrium. So these are the things that we know, and with all of this we can actually solve this stupid problem. Although, we'll admit, it is a bit of a faff. So, how do we get that? Well, step one is to say, if the force up equals the force down, then the force of the friction of the wall, force friction wall, add the reaction force from the floor, which I'm going to say is force floor, because they're the two up forces, must equal the force of the weight down. Now you might say to yourself, what about the force of the wall, the reaction force of the wall, and the force friction of the floor? Well, crucially, they're at 90 degrees to all the up-down forces, and therefore will just go to zero if we only consider things in an up-down plane. Because whenever we move a force through an angle, it goes from maximal force all the way to zero force as you get to 90 degrees, just splitting a vector into components. So there we get that. Then the force left must equal the force right, so the force of the reaction force of the wall must be equal to the force of friction from the floor. Simple enough. Now things get a lot fiddlier, because now what we can say is clockwise moments must equal anti-clockwise moments. Now a moment is defined as the force multiplied by the perpendicular distance along the line that you're working along. So whenever you're working out moments, the first thing to do is choose the point around which you are taking moments. So if we go back to this pen, if it is balanced here in my hand, then you could take moments around this point and say the mass down here plus the mass down here must equal my fingers up here. Or you could take moments around the middle, in which case all the stuff in the middle would disappear, and basically the turning effect here must equal the turning effect here. You take moments around any point and it will still just go to zero. So what we're going to do is we're going to take moments around the middle of the ladder. And what that will allow us to do is get rid of the weight of the ladder, because the distance between that and our fulcrum, because we can put an arbitrary fulcrum wherever we want, because that's going to go to zero, because the distance is zero, we can just ignore this force. Unfortunately, what we've now got to find out are what are the components of each of the forces at 90 degrees to the ladder, because they're the components of the force that will provide a turning effect. So this force here, the force of the floor, we want this bit of the force of the floor, we want this bit of the force of the friction of the floor, we want this bit and this bit of the force of the friction of the wall and the force of the wall. Okay, so we can see very clearly that this component, and this component are all acting clockwise, and this component here is the only one that's acting anti-clockwise. So this component of this force must equal these three components all added together. I won't bother you with the angles. Basically, whenever you move a force through an angle, so if I have a force here, force alpha, this is going to be F cos alpha, and yeah, so whenever you move a force through an angle, you end up with the force times the cosine of the angle, which is why when it's at 90 degrees it goes to 0. So if you work out all the relevant components, you will end up with, quite neatly, the length over 2 is going to be multiplied by all of them, because remember, moments is force times distance, times the force of the floor cos alpha is going to, so that's this bit, is going to be equal to length over 2 times the force of the friction of the floor sine alpha add L over 2 force of the wall sine alpha, so that's that bit moved through that angle, add L over 2 force of the wall cos alpha, I think? Force of the friction of the wall cos alpha, is that right? Yes. Force friction of the wall cos alpha. You can get rid of all the L over 2's and simplify, and that will give you force of the wall sine alpha add force friction floor sine alpha add force friction wall cos alpha is equal to the force of the floor cosine alpha. So you get to this point here. Okay. Now, the way you solve it from here, and to be honest, there isn't too much point taking me through the rest of it, but there are just basically two other tricks. The first is, you know that the force of the wall is equal to the frictional force of the force because of the left-right ones, so you can use that to sub in. So that gives you something to work with. And you also know that the force of the frictional force from the floor is going to be equal to mu times the force coming off the floor, because remember, whenever we have a frictional force, it's just equal to the coefficient of friction multiplied by the reaction force. So you also get this for free. You know that this must just equal the same coefficient times that. So if you know that and sub it in, you know that and sub it in, you end up with, and I'm going to send you the link as well, or actually I'll put that underneath the video, that will just end up with some tan alpha equals 1 minus mu, you end up with, and you have a no, yeah, mu wall, mu floor divided by 2 mu floor, and you can solve from there. Okay, but again, hopefully once you get to this, this and this, everything will just be maths, which is where you'll be better than me. Okay, hope that helps.